Well, thank you so much for that intro, and hello everyone. My name's Priyanka. Today I'm going to be talking about AI bias. It's a hot topic in the field right now, and I'm really excited to get into it. Before I do that, though, quick intro about me. So my name's Priyanka. I've been in AI since graduating, first as a software engineer, and then as a product manager at both Tesla and Google. Obligatory disclaimer, these views are my own, but it is a bunch of, this is essentially a collection of experience and knowledge that I've accumulated over the course of my career that I want to share with you now because AI is growing, it's becoming much more ubiquitous, and a lot of the challenges that were present in the early days of AI are still present, and they're scaling and they're getting more and more reach. And so it's very important that as AI becomes a bigger part of product management generally, we all have some frameworks and tools to address what is one of the biggest topics, which is how do you prevent AI bias from seeping into your products when you think about launching them? And so with that, what am I going to cover today? Well, a couple things. First, we'll start with some very common examples or some very high profile examples of cases where AI bias was shipped and caused damage to a product. And then we're going to talk about how you can actually measure the bias in your products and how you can actually get a sense of what is going on in your products that you're trying to launch. And then the most important thing we might talk about today is how to mitigate it. So very practical steps you can take after you've determined what bias exists, how you can prevent that from causing more damage to your launch. And then a bit of a risk framework so that you can evaluate and manage stakeholder expectations when you're launching AI products. Because the reality is AI is difficult to eliminate risk completely. And so we need a way to think about it and decide whether or not to launch our products. And so let's start with some examples. How many of you have heard of AI bias? Just like if you raise your hand in the chat or in the Zoom. You've probably heard a little bit about it, right? But it's not new, right? So even going back to, what was this, 2014, there was several studies done on resume screeners, and what they found was actually they took the exact same resume, it had the exact same qualifications, and they sent it out to a bunch of STEM professors and STEM positions. But there was one difference. They changed the name at the top of the resume from John to Jennifer. So half of the resumes had the name John at the top, and the other half had Jennifer. And what they found is that John was seen as consistently more hireable, more competent, and got a higher pay than the resume with Jennifer, even though it was the exact same. And so this bias was present not necessarily in the algorithm used, but when people were just evaluating resumes, when people were screening resumes, they preferred male candidates. And these were professors, these were very educated people, and even women tended to prefer John as the candidate that they would hire. So what does this mean? Well, so if some companies were trying to build automatic resume screeners and they wanted to learn from historical data, what would happen is they would take that historical data and say, oh, here are all the resumes of people who were hired by our company. And 90% of that data, 90% of those people who were hired were actually in this majority class, let's say male for this example. And some much smaller percentage was in this minority class, say female. So in STEM professions, the resumes of people hired tended to skew male because of the human bias that was present in the original hiring. And so what happens is you get into this horrible cycle where you have a loss function that penalizes the model more often when a minority class is predicted higher. So for example, if you're training your model and it sees a lot of men coming in as successful, and every once in a while it'll guess, hey, a female should be hired, and that's wrong, right? That's not seen by the model as much. And so it learns actually to index on something that you don't want, which is gender. And so what it does to minimize its loss function is it predicts no hire exclusively based on gender. And it does quite well because of the skew in the data set. And then what happens is your model says 99% accuracy on your data set. Great. And you want to deploy it and you start using it to automatically filter resumes. And then recruiters start to see more resumes from this majority class. And if you have some type of feedback loop, you put all of those successful candidates back into a training set, and you go into this cycle where it's very difficult to get out of it. And so that's why it's very important to try and assess bias before you launch a model, because you can actually perpetuate it if you're not careful. And so one easy thing that people thought is, let's just ignore these demographics completely. Let's take our data set and we'll scrub it from gender. We won't have any classes, like we'll scrub all obvious mentions of gender and race and all of these historically, all of these demographic information. But what we found is that isn't sufficient. So some of you may have remembered this high-profile case in 2019 where Steve Wozniak applied for an Apple credit card and his wife applied to the Apple credit card. And his wife got a much lower credit limit, despite the two of them having very similar credit scores. They're married, so their financial situation looks the same on paper. So they have similar credit scores, very similar financial situations, but his wife got a much lower credit limit. And he called this out. It was very public. And what was Apple's response? Well, Apple said, hey, we had a third party audit this, and we don't train on gender. So it's not our problem. It's not our fault. Needless to say, it was a big deal. This did make headlines, and Apple had to do a lot of damage control. And the reason that scrubbing the data of gender wasn't enough is because you actually find that in data sets, there's heavy correlation between certain demographics and other correlated variables that you may not think about. So a very common set of variables that are correlated to race are zip code, name, where people travel and live. So these are actually very highly correlated. And so if your data set, if your model takes as input zip code, it's very highly likely it might actually learn a person's race and bias against or towards that. And gender too, if you think about some of the biases that can sneak in when you're building a credit card application or a credit card approval system like Apple was doing, well, purchase history. Women tend to buy more beauty products or they tend to buy female-leaning products. Employment history, women may take some more time off because of childcare, et cetera. So there are highly correlated variables that can actually serve as proxies for some of these demographic information. And so scrubbing becomes insufficient. All right, and then another added hurdle is that the field keeps changing. Some of you may remember back in 2015, Google had this big scandal where when you typed in gorilla, a bunch of people who were Black would show up in their Google Photos results. Of course, Google apologized and scrubbed it, but fast forward 10 years, and suddenly they have a new struggle where they cannot, and for the first launch of Gemini, they really struggled to put something out. And when people tried to test out, say, here we have a medieval British king, the model wouldn't show people with white skin. And so it's a constant back and forth. And what I want to highlight with this is Google spends so much time and so much money thinking about bias and trying to prevent bias from happening. And still it happened, right? So if you're at a company and it's spending less than Google, it's not a question of if you will have something, if you will have a launch that will result in some biased results. It's more a question of when and how do you mitigate it. And how do you stay on top of it? And that's why this discussion is so important, is because it's not a static field, it's constantly changing. All right, so let's keep going. Now that we've gotten a good overview of some of the types of biases that you can see and that have caused companies a lot of problems, what can you as a product manager do to actually prevent it from happening in your launch, or at least mitigate it? And the first step is you have to measure it. So how do we measure bias in your data set? Let's take a look. In order to do that, first let's understand a little bit about how machines learn and where this bias can actually sneak in. And we'll take the example of word embedding. So natural language processing, chatbots are becoming very big. So let's take this example. So we have a sentence. It's the quick brown fox. And we want to take that and embed it so that a model can learn from it. What actually happens is we don't take the raw text and give it to a model. A model or any AI algorithm actually needs to see this text in the form of numbers. And so there's this step when we do machine learning in converting our input into a vector or a set of numbers that the model can then compute weights, derivatives on, etc. And this process is quite prone to bias because in order to take some words and convert them into numbers, models and the embedding models that we use try and take historical data and find correlations between two words and then embed that into a vector space. And so what happens is you'll often find that when two words are seen together frequently in text, a model will consider them to have similar meaning. So let's take a quick example. Let's say we have a two-dimensional vector, two-dimensional word embeddings, and we want to see their meaning. We want to see how similar these words are. And so your model takes, the historical internet data and it finds that woman and queen tend to be shown together in texts and documents. And so it thinks they're close together and it learns this representation where in this vector space, a woman and a queen are very close together. And man and king are very close together, and they're considered similar, right? So a woman is more likely to be a queen and a man is more likely to be a king. This is essentially how a model sees meaning. It's how distant are these two embeddings in the shared vector space. And in the case of woman and queen and man and king, it's not as big a deal. But what happens is in historical documentation, women are often seen as caretakers. These two words tend to appear a lot in historical documents, and man and provider is also seen a lot in historical documents. So because these words are close together, a model might interpret them to have similar meaning. And then it sees caretaker and nurse as two words that are very similar, and then provider and doctor as two words that are very similar. And then you start to see these clusters, right? So on the left, you see female type terms, and nursing might be something. Let's say you're building a resume screening. It might learn that women tend to be nurses and men tend to be doctors. And this is a problem, right? So this is where bias starts to emerge, is because the model doesn't actually understand the meaning of doctor. It really has just learned correlations between doctor and words that have appeared in text frequently with that word. So how do you measure this type of correlation? Because often embeddings are very multidimensional. I showed you a two-dimensional example. Sometimes they can be hundreds of dimensions. And one example of how you can measure this is through a word embedding association test. And these models, these techniques are very open source. They're very available. But at a high level, what this association test measures is the similarity between two words. So the score can range between 2 and -2. And here you can see an example, the first row, that flowers have a strong correlation with pleasant, right? That's what the 1.5 means, relative to insects. So when it's comparing flowers and insects, it considers flowers to be pleasant and insects to be unpleasant. And so the higher the number, the stronger the correlation. And as you can see, also, different open source embeddings may have different biases. So the glove vector, which is a very common vector, tends to have a certain bias that, for example, the third one, the 50 dimension English language one, does not. You can see that in the European American pleasant versus unpleasant, where the bias is actually much higher for the glove vector. And a lot of open source type vectors are starting to take into consideration these associations, and you can measure them yourself and pick the one that's best for you. So let's take an example here is if you want to potentially create a model that determines whether someone's good at a math or an arts related program, it might actually be better to take the glove vector than the center vector, or the glove embeddings than the center embeddings, because they tend to have less bias in this particular dimension. And so a question comes up is, well, what are all the correlations I have to be concerned about? Obviously, race and gender, but what's the full list of things that I need to measure this embedding association test against? And the answer is it actually might vary depending on your use case, because there are strong associations built into language for things you might not expect. Even here, we see an example, and sorry, the text is a little small. On the right, you see that there's actually a bias in some of these embeddings for the northern dialect in the US versus the southern dialect in the US, where certain words associated with northern speaking Americans are often associated also with higher paying jobs, or more white-collar jobs, such as environmentalist or neurologist, while as the Southern dialect is associated with things like fisherman or hairdresser. And so, again, if you're thinking about a resume screening system based on just chat, this type of dialect bias might sneak in as well. And so I know there's a lot of thought about like, how can I actually, what's the actual tools you can use to measure this bias? And there are some open source tools for measurement. If any of you are using Amazon, there's a lot of great tools in SageMaker to help you understand that class imbalance and your label proportions. And then IBM has a lot of open source material that you can use. And it even has some stuff that you can use to edit your feature values directly. But the reality is, in your use case, you'll need to build your own to be very confident about the bias in your data set. It's nice to rely on some of these tools, but as an AI product manager, you want to have a deep understanding of what the risk surface area is for you. And these can be, an even great, a deeper talk, but we have limited time, so I do want to keep moving to talk about what is probably the most interesting, which is how do you mitigate the bias in the data set. So it's like, great, you measured it, great, you know what's going on. But in order to ship it, you have to ship something that isn't so dangerous, or you need to reduce the risk. So what can you do? Well, here's the range of areas where you have an opportunity to mitigate, right? And generally, it's broken up into 3 categories. The first is pre-processing. This is in your data set. This is before your model trains anything. You can mitigate the bias in the distribution of the data that you've collected. And this way, the model sees a much more fair representation of what it is that you want to learn. Second, you can actually do some in-process mitigation. And so this is during model training. You can have your algorithm learn to recognize bias or reduce bias during the process of learning. And the third is post-process. After you've trained your model and you get your predictions, you can actually smooth those or edit those so that the bias does not ultimately affect your final product. And so we'll go through some examples of each of these steps. So in pre-process, there's a lot you can do with the data set. So here's an example on the left where you have an unbalanced data set. In this case, we have a lot more cats than we do dogs. And so if you just naively train on this data set, your model might learn to just always predict cats, right? That will get it 90% accuracy. It'll minimize the loss function. And that's not what we want, right? We want the model to actually learn what's in these images. And so the easiest thing to do is just get more data of dogs, right? If you see that there's a big imbalance in classes, find more data for that other class. And if you can't just collect that data from the wild, there are a few techniques you can use. You can try and collect it, but you can also augment your data where you take a picture of a dog and you modify it, modify the color, modify the position. Now there are tools with generative AI where you can just generate a bunch of pictures of dogs. So there are a lot of things you can do in this case. And then you can also take, so that's what I mentioned. So data augmentation is you take your existing pictures of dogs and you modify them slightly. And then synthetic data generation is you just actually take some of these generative tools and you make new data. So this is the easiest thing to do. But what if you're strapped for cash? What if you can't actually find this data? What if it's very rare or it's very difficult for these tools to generate? Well, during training time, you can actually take an unbalanced data set and make sure the model sees a more balanced representation. And there are 2 ways to do this. One is through undersampling. So what happens is at training time, you don't actually show the model as many pictures of cats as you have. You show the model a proportionate number of cats and dogs. So that way the model doesn't see a disproportionate set of one class, and it actually learns on a balanced data set. The other thing you can do is oversample. And so what happens here is you just take the same pictures you have and you show it to the model more often. The main goal of this sampling method is to make sure the model doesn't maximize or doesn't optimize by just guessing cats all the time, right? The main goal is to get a proportionate data set across all your classes. So that way the model doesn't overfit to one type of class. So this is a very common training technique. It happens a lot because data often very common for one class to be much more sparse than the other. And it's very good to use to prevent bias, not only in demographic information, but just in model quality, right? So this is very easy to implement. The second thing that is becoming more common is this concept of adversarial debiasing. What does that mean? Well, some of you may be familiar with GANs, which are generative adversarial networks. And what happens in GANs is there's a generator and a discriminator. And what is happening here is the discriminator is trying to learn between a real and a fake image, while as the generator is trying to create an image that will trick the discriminator. And so this technique, in this technique, both these models are trained simultaneously. And they've taken this approach and applied it to debiasing. And what that means is you have one model that is trying to determine whether or not, basically you have one model that is performing your task. It's trying to predict resumes, it's trying to predict people, it's trying to do something. And then you have another model that is trying to trick that model. It's trying to get that model to produce something biased, right? And so this setup is very similar to the GAN setup, where these two models are trained simultaneously. And what happens is your adversarial network will get better and better at producing fake results that are biased and get better and better at tricking your predictor. But your predictor will also get better at determining that something is biased and still producing an outcome that is fair. And so this joint training technique is something that's becoming more common. The other thing that you can try is during training, you can actually modify your loss function. So a quick review of loss functions for those of you who might be newer to the field. But basically the way a model learns is you have a bunch of examples, you have a bunch of correct examples, and you have a bunch of predicted examples. And then the model during training time calculates the error between what has been predicted and what is truth. What is your ground truth? And so what you can do is if you have a sparsity for minority classes, you can actually increase the penalty for guessing wrong on one of these minority classes. Here's a naive example. Let's say we double the penalty for a sensitive class. This is a technique you can use. Of course, there are some drawbacks and trade-offs. One example is if your data set changes over time and you're retraining your model, you might actually run into problems where you're biasing too much towards this sensitive class if that class grows over time. So this is a tricky one. It's a very nuanced one, but it is something you can use to bootstrap, which is like, let's say you have, very few examples of a certain demographic. You just say, hey, we'll build it into our model to actually penalize that more for getting it wrong. And then one that's probably more popular and more common is after you predict things, you can relabel or smooth the predictions to be more representative. And there's a few examples of this. Here's one example. But the idea is you have a fairness score and you have a certain demographic or a certain variable that you're measuring this against. And if there's a huge bias, for example, in this case, where all females are rejected, your model, your post-processing model can actually smooth it so that it looks at other features, that it looks at these predictions and then creates a more fair set of predictions based on this model. And so, of course, there are some challenges here as well, because you'll notice, for example, the model predicted X5, this male, to be accepted, but your smooth predicted label predicts a rejection. And so there might be some challenges in that balance, but it is something you can look at scale. And the one that is probably the easiest to implement are just heuristics or guardrails. So what does this mean? It means after you get your model predictions, you can create a disallow list for certain terms. So for example, if you're creating a search product, you can just disallow searches for all primates on the front end. And then you don't have to worry so much about the one-off cases where your model might make this mistake. Or you can do other user input constraints, like, hey, you can't actually look for images at all. We only allow you to search for text. Or you can create a bunch of UI disclaimers on intended use. Or a very common one in self-driving, for example, is you put a human in the loop to actually verify everything. Or if you're in some type of, so like, for example, if I'm driving, right, you might misdetect a person, but you have a human who's there who can correct the machine before it causes a real problem. So guardrails are very popular for product managers, but they often fall on this scale, right? Where you can have very, very narrow product. You can have a lot of guardrails, which creates a very narrow set of things that your model can do. And this is lowest risk, but it's often low utility. Or you can be completely unrestricted, like the original version of OpenAI's ChatGPT, which is kind of high risk, but it is very high utility as well. And PMs have the most control over this slider. Like you can choose what your product constraints are much more easily than you can go to an engineering team and say, change your loss function, right? So this is something that I've used a lot and that often gets put and that you can modify after your model has been changed or even after your product has been launched. So it's very good to be familiar with the types of guardrails that make sense for your product. Cool. And so now I want to talk a little bit about how you can take all this and put it into a framework that you use to discuss with your stakeholders. So we got into some detail, but I want to take a high level approach to the key stages of shipping an AI product and considering bias throughout those stages. And the first stage, which we talked about a lot earlier, was the technical mitigations you can take. So during your process with engineering, you're talking to them about how you can measure bias and what your KPIs are for bias. And you're selecting key scenarios that you're concerned about. So often your engineering team will come to you and say, how do we know we're good enough? And part of your job as a product manager is to say, here are some abuser scenarios that we need to think about. Here are some cases I'm really concerned about, and discuss some of the guardrails that might make sense. And then the second thing you need to do is often what happens is the engineering team, they go, they train their model, they do their best. It doesn't quite get to 99% accuracy, or there's still some risk that you can't quite shake out without potentially really limiting the usefulness of your product. And so this is where you need to go in and understand, what is our communication strategy for when something goes wrong? Do we need to pull in any third-party audits, and how are we doing internal red teaming? And then what's our rollout plan? How do we do this in a way that is safe so that we can catch any unknown unknowns before they impact, protected or vulnerable demographics? And then the third thing you need to do, and you need to do this with all products, but especially for AI products, is you need to monitor it post-launch to understand how data sets might be changing, to understand the sentiment of your feature, and you need to have an update strategy. So for example, you can't just, you should be ready to potentially even pull the feature back if it's not operating in a way that you think is responsible. And often the hardest part of this whole process is the launch decision, because at this point, there is still a lot of uncertainty in how things are going to shake out when you roll it out to people. And what I've talked to, when I've talked to a lot of people, I'll give an analogy. I've talked to a lot of lawyers, and they almost never say, we're going to block this, or we're giving you a yes or no decision. What they always say is, we're giving you a spectrum so that you can understand the risk. We're giving you a framework so that you can understand risk. And with AI bias, it's the same way. You'll never fully eliminate AI-related risk. You can reduce it, but what's important is to lay clear the types of choices and the levers that you have, and the relative impacts that those choices might make. And so that's what I want to show you and walk through some examples with you today. So what do you do? How do you create this discussion point? And how do you create this framework? So first thing I like to do in scenarios when we're thinking about a feature is to list all the potential sources of bias that could be present in my product. And so what does that mean? Well, we talked a lot. Is the data set skewed? Have certain demographics been historically excluded from this particular prediction that I'm trying to make? And then what biases will be difficult to remove entirely? So there are some biases you can mitigate, but there's might be some that you just can't get rid of. And what are those? It's important to list them, and so that, as early as possible, so that you can start to think about other ways to mitigate them. And then what are the detailed scenarios for misuse? So what are the specific ways that this product could be used for harm? Put yourself in the shoes of someone who wants to make you look bad, who wants to damage a group of people. How could this go wrong? And really get into the details of that. And then how much risk is your company willing to take on? Different companies have different profiles. So if you're at a defense company, that might be very different from Microsoft. That might be very different from OpenAI. So get a good understanding of what kind of risks your company is willing to handle. And then these two things from this can then inform your guardrails. So how do you train your model? What capabilities do you limit? How much are you willing to invest in some of these tools? Because it can be expensive to retrain your model, to do a lot of experiments, to not use off-the-shelf tools. How custom are you willing to go? And are you willing to really limit the capability of your model or not? And then what's your go-to-market strategy? What will you say in some of the scenarios that you determined earlier? When one of them happens, what's your communication strategy? How quickly can you update the feature? And where will you roll it out? How can you make sure that it's rolled out in places that your model is optimized for? So let's take some example. Oh, first, let me give you a little deeper dive. Like if you want to double click into risk, you can actually take each of your scenarios that you listed here, so your scenarios for misuse, and then just create a risk matrix, right? Like how likely is this scenario to occur? What is the impact to the demographic that it might impact? And what is the impact to your company? And then what are the trade-offs of trying to mitigate this scenario further? What are the trade-offs in utility that you might be able to make? And so let's do an example, right? Let's try this out together. And so what I would like for you to do is to type into Zoom some of your thoughts. Here's a case study. Let's say you're an AI PM and you are trying to safely launch a feature that generates websites based on a text prompt. So let's think about one case, one scenario where this could be abused and one way you can mitigate that abuse. And so I'll give you 2 to 3 minutes. Just go ahead and type it into your Zoom chat here. And then we'll review and see how it goes. Does that sound good? Cool. I'll give you a couple minutes.
All right, we got started. So it's 10:05 right now. We'll go until 10:07, but feel free to just like type it in our chat box. All right, I think it's been about 2 minutes, so maybe we can get started.
Yeah, these are some great examples. Cool. Let's take the first one. Very interesting, is a hate website. And so the idea is you would type in a prompt against a certain demographic, and then we'd create a website for that. And obviously very bad, right? And a cool mitigation is a guardrail mitigation, which is just to have filters, maybe even a list, right? There are open source list of a bunch of terms, and then restrict people from typing those terms in. And then you pretty solidly mitigate against that case scenario. So that was a great example. Another interesting one is fake news. So someone wants to create a fake news website. And this is an interesting topic because how do you know, how can you mitigate it? What is something you can do to prevent fake news? And we can discuss some of these earlier or discuss some of these later, but I think it's an interesting trade-off because can you actually determine if something is true or not? This is a big problem even for the big players. And so if fake news is a problem that might happen, do you need to mitigate it? That's a question. And if you can't mitigate it, should you launch it? These are two questions that a product manager should answer. And I can go into some details about that as well. Let's see. Oh, this is an interesting one. Dig out the source for many articles and use that as a source of truth. So yeah, you can use some RAG and then you can create your own database of truth and then only create news-based websites based off of that. Preferred sources of truth for fake news. Yeah, so this is a cool mitigation. Can your company manage that? That might be something you want to talk about. How often would you update that? That's something you might want to talk about with execs, but these are cool mitigations. So maybe we'll come back to some of these at the end, but for the sake of time, let's go through this exercise with the framework I outlined on generating a website from a prompt. So what are some of the sources of bias that can be here? Well, One example is often a lot of websites tend to have Western UI preferences, or this, if you've heard the acronym WEIRD, which is Western educated, they tend to bias towards that. So if you're trying to build a website, a prompt-based website globally, some of your international customers might find this problematic. Additionally, if you're trying to build a website that supports professional services, some demographics have been historically excluded from certain professions. And so that's an important source of bias to keep in mind. Some of you have produced some cool examples in the chat, but some scenarios for misuse is someone creates a website to further a cause your company disagrees with. And this comes back to hate websites, some biases related to, fake news. Here's one scenario. These are some scenarios you brought up. So what are some guardrails or trade-offs? So we mentioned this. You disallow hateful prompts, right? Another guardrail you can think about is, hey, image generation is pretty dicey. We don't have a lot of control over it. So maybe we only allow people to generate images of inanimate objects. So when you type in that prompt, if we're going to generate images, we won't generate people. We'll only generate text and inanimate objects. And then maybe you have a human review required before publication. So you don't just create this website, maybe you create 3 or 4, you have the person on the other end decide whether or not it's good enough before publication. And maybe that's good enough as you have the customer in the loop all the time, so the company doesn't take heat if something published is bad. And then after launching, as you're thinking about how to go to market, maybe because of the source of bias of Western material, maybe we should only roll out in the US and EU first, and then only roll out some partial or very limited features in other countries so that we can collect data and build a less biased data set in these other regions. So this is obviously not comprehensive, but it's a way you can sort of map your sources of bias to mitigations and map your scenarios for misuse to other mitigations on the right. So let's see what this risk matrix might look like. Some of you mentioned the hate websites. And let's say we put some mitigations in where we have a list of hate terms we don't want, but the reality is it's hard to get around all of the ways a human can generate hate or get a prompt to make something hateful. And so we think it's actually very likely that this will occur. And it could have a big impact on the affected demographic. But when we think about the impact to the company, maybe it's actually quite low, because if you think about websites generally, a person can publish a website without AI that is very hateful. A person can use a lot of other tools to create hateful content. And so maybe it's not as big a deal if this prompt can't restrict every single type of hatred if it does a best effort. Because the restriction, let's say we create even more restrictions, suddenly the feature doesn't become useful at all. So we think this is a sweet spot, and we think that if we were to generate something, if someone were to bypass our filters, it wouldn't actually harm our company that much. This is an assessment you have to make. I'm not saying this is the right assessment, but this is a way you can think about it. And then you can take this to executives and you're like, look at all of our scenarios. We think the impact to the company for these scenarios is actually not that high. And so I'd be okay with launching it. And maybe your executive comes back and says, I actually would like us to work more on scenario 2, where we're generating images that are too Western before launch, et cetera, et cetera. And what happens is you get a very concrete, very productive conversation with stakeholders about what they're afraid of, what they want to mitigate, and how much they're willing to invest in the mitigations, and how much they're willing to invest in measurement. So this is something that I've used in previous cases, and it varies depending on the type of feature you're launching, right? So this is generating a website from a prompt. What if you're trying to assess a security threat via drone? Very different problem space, but you can still use the same framework. Like, for example, if this drone misidentifies an innocent person as a threat, that's huge. That's terrible for that affected demographic. They might be arrested incorrectly. They might suffer physical harm. And so you might actually decide not to launch this feature because of the demographic information or demographic impact and the company impact. But maybe your executive comes back and is like, look, if we can get the likelihood of occurrence to be extremely low, then maybe I'd be okay with shipping this because that's our risk profile. And a lot of self-driving cars actually fall into this risk profile where it's like, hey, if we hit a person, that's very bad, right? We don't want to happen. And so our goal is to make the likelihood of this happening almost zero, as low as possible. But we're willing to take that risk. And so this is why I say it's important to know ahead of time what the risk profile of your company is, because many companies would say no to this, but maybe some companies would say yes. And this framework helps you have those discussions in a way that doesn't feel circular or too big, right? And so what we've talked about so far are these known knowns, right? So we know race, we know gender, we know wealth. These are certain demographics that we know and can measure, and people have made mistakes in the past, and we can learn from them when we ship our own products. But what about this other bucket on the right is what are the unknown unknowns? Like Google, when it launched Gemini, it didn't know it would have to check for this bias against lighter skin in certain in certain queries, right? It didn't know until it launched. So how do you, as a product manager, build confidence in your product without launching? And the answer is really you can't. So the challenge of AI is there are so many unknown unknowns, and you might not be able to test them ahead of time. And so that's why your go-to-market strategy becomes so important, is because you discover these things during rollout. And one question we often have to ask ourselves is, do we want to be the first ones in this field, or do we want to wait for others to clear the minefield? And if you're an innovative company, if you're pushing the boundaries of foundation models, then you probably have to be the first. There's a real first mover advantage. But if you're, for example, generating prompts for a website, and you're really just creating a wrapper around ChatGPT or some other foundation model, then do you really need to be the first one in that field? That's a question you can ask, because it's not too hard to catch up to others who are just building wrappers around ChatGPT. And so if you want to mitigate these unknown unknowns, you can either very cautiously roll things out, monitor, collect feedback, or you let others do that for you and learn from their mistakes. And then this again comes down to your company's goals, its brand, and what its strategies are in AI. So what's next, right? We talked about historically what's been happening. We had some interesting case studies, which I'm happy to discuss more in the Q&A, but how do we think the field of AI bias is going to evolve? And so I'm going to make some predictions. Obviously, predictions are going to age poorly after some time, but given the trends of what's been happening, here's what I suspect will happen in the world of AI bias. So first, right now, what's happening right now is people are establishing technical best practices. We have some for word embeddings. We're starting to get some for this image generation and text generation. And then, industry players will start to converge on what makes the most sense in conjunction with some independent third-party groups. And we'll start to see standards for AI safety being set. We're already seeing some regulations come out of the EU. We're seeing some organizations like NIST get involved in AI bias, and we'll start to see some best practices be adopted in the industry. And then after this starts to happen, we'll start to see a public understanding of the limitations of AI. So when a customer sees a chatbot, they'll know that they need to use other tools to supplement the fact checking of that chatbot. And what I imagine will happen is similar to how we accept and understand that our cloud services or other services may be hacked, that there are some security vulnerabilities, but we still use them now. We'll start to understand that AI might have some pitfalls, but we'll start to accept them and build our lives in such a way that they don't damage them and that these shortcomings don't hurt us. And so I think we'll start to see an ecosystem build up around that. And then we'll get to this world where AI is so ubiquitous in every product that mitigation becomes very easy to check and audit. There will be lots of tools you can use. There might be full tech readiness programs that you can just use as a checklist to say, yes, we've checked all the boxes and we know our AI bias is within spec and causes minimal harm within, reasonable constraints. And so if we move in this direction, I think AI bias will start to become something that we're all aware of. We all try and think about when we ship our products, but not something that causes anxiety, not something that causes us a lot of stress when we're thinking about how to ship a product responsibility. That's my hope. But what we'll notice here is I think a lot of it comes from the industry players and what people are shipping. And this is why you as a product manager actually play a big role in the future, is because what these government agencies, what these public will start to do is they'll look at what's happening, what's being shipped. They'll ask product managers in the field, what have you been doing? What are the things that we should do? And that is what will become solidified into best practice. So as you ship your products, you're actually shaping the field. You're actually shaping what will become law in the future. And so it's great we're having these discussions. It's a great changing field. And just to summarize what we talked about, when you're shipping these products and trying to mitigate bias, learn from the past, from whatever situation you're in. There's some company that has made a bunch of mistakes and you can learn from them. The second thing is to measure the bias wherever possible. And then the third is to mitigations, but note that they will reduce risk, but will never eliminate them, which is why you need to be able to discuss risk on a spectrum, discuss it in a framework, understand the trade-offs, and understand that the trade-off is usually utility. And that's a great way to think about how you want to ship these things responsibly, because it can be done. And you guys are, we're all the front line on defining what becomes industry standard. So with that, I will thank you all for your time. I hope this was useful. I hope this was helpful, and we can turn it over to Q&A. I see that there's some questions in the chat. Maybe I'll start there, and then we can keep going.
Yeah, sounds good. Thank you so much. First of all, this was a great presentation. I find it very, very helpful. And for those of us that are part of the cohort right now, in our upcoming sessions, we'll also be digging more into some of the topics related to responsible AI and how to launch products responsibly. We actually have a workshop in the coming week in that area. So hopefully you guys will get that. And for those of you that are interested in signing up to the cohort, please use the link that we shared earlier. But maybe I'll read a couple of the questions that are posted. I think the question that Jitsna posted I thought was very interesting. She's asking, like, can you share an example of a situation where the leadership didn't agree or were convinced with the risk analysis for launching an AI-powered product, and like, what was that conversation like, or what was the outcome? Maybe without getting into like any sort of confidential information, you can kind of share at a very high level, like, what is that conversation like? I think that's kind of more the question.
Yeah, that's a great question because it happens a lot, right? The part of the risk analysis is that it is a conversation. And so often what the conversation will go like is there'll be some question about, do we have numbers? Can we quantify the impact? What are the examples? And then there might be some discussion around, well, I actually think the value is higher. I think if we go with the mitigations you have, we actually are really restricting the product too much. And so I want the value to be higher. Or it might be like, hey, I disagree with how much impact that this will have to your selected demographic, or, how do we know that it will have this kind of impact? And that's difficult to quantify. And so often that becomes a discussion, and it depends on your executive's personality. I think I can give one example where we were thinking about the risk, the likelihood of something occurring. So this is something you might actually be able to quantify both through your offline test sets and some beta tests and some bottoms-up analysis, is how likely is it that a certain scenario, let's take, trying to avoid confidential information. Let's take, how likely is it that we're going to detect cats, right? How likely is it that we're going to detect cats instead of dogs? And what are the specific cases where that may happen? And so we think we're going to detect cats instead of dogs, like, 20% of the time. But when we dig into those cases, it actually turns out we're going to detect cats instead of dogs mostly at night. So then we can actually implement this guardrail where we say we won't run this model at night. And we actually do a very good job during the daytime. So the risk, the likelihood of something happening can go down a lot when you dig into your data set. And sometimes the executives will prompt that, sometimes engineers will prompt that. And so that's maybe one example of when the leadership didn't agree. It wasn't like, hey, I think your risk analysis is wrong. It was more like, hey, can you justify why you think it's high or low? And then that discussion will reveal cases or ideas for how you can actually reduce risk or increase utility. Does that kind of answer your question? It's more like a discussion point than like a be all end all.
Yeah, that makes sense. Thank you.
All right,
Cool.
awesome. Thank you. And then one more question that I thought was interesting, posted from David. So his question is like, how do you make sure that these preferred sources are not biased themselves? And
Mm.
yeah, it's an interest, like basically he's saying like, what if the preferred sources of truth for themselves are like some sort of like fake news,
Yeah.
source
So
of
this
fake
is,
news?
yeah, that's a great question. And I think this is a kind of the challenge that you might have depending on your use case. So for example, let's say you're talking about building websites. Often the best you can do is rely on, let's say you really want to be super conservative and super safe, right? So you can only reference, maybe you say we only reference published research. We only reference university documents. We only reference websites with a .gov or .edu domain. So that's a super conservative approach to making sure your database of information is fact-based. Maybe you go a little bit more useful where you include some news sources like AP News or cases that or news sources that are generally reputable. And then, obviously the highest utility, highest risk is we allow unstructured data from the internet that, top hits on Google or something like that. Or we hand curate our set of information. But of course, then it's subject to the bias of the person that curates it, right? So that's the high risk. And so I would encourage you to create that spectrum of like, what is the most conservative approach and what is the most least conservative approach? And then use that sliding scale to determine how much risk you're willing to take in generating fake news. Because if you have a really low risk tolerance, then you need highly vetted sources, and you can get that, but it might restrict the utility of what you're creating. So again, it's kind of the spectrum. You'll never completely eliminate it, but there are ways you can reduce it.
Thank you so much. Thank you so much for that answer. And we'd love to have more questions answered. But basically, what you were saying is like it doesn't necessarily pass the Turing completeness for finding the truth, which is a very interesting point. Yes, somebody's asking, will we get the slides? Yes, all this stuff will be available. You'll get it in the weekly newsletter at PM Exercises. We only have a couple minutes left, so I wanted to invite somebody from our current cohort, maybe quickly share their experience. A few people showed interest. Maybe we'll have like Swati. I can see her right here on my screen. Maybe you can kind of share like what the experience has been so far. That would be great.
Sure, Bijan. Thank you. So hopefully I do justice to my experience thus far. So before I talk about what I've been enjoying about it, let me just give a brief background, like, where I started from. So I was product manager at Amazon at Flexport, and I come from a strong background of data and some research modeling experience. So I really came initially thinking I really want to learn about Gen AI and see what it's all about. And I'll tell you three things that I've really enjoyed, and I strongly recommend this if you can't tell this. One, I've loved the instructors, and it's whether it's Mahesh or it's Kai, everyone is so hands-on. These are people that understand not just the theory, but they've actually done hands-on stuff, building products at scale. Because the challenge is not just knowing the theory, but how do you translate it into the real world, right? So they come with the theory and the knowledge of how to build it. Second, everyone that I've worked with that is so amazing in terms of giving and sharing, whether it's Bijan, it's the instructors, anyone in the course. So, and if you are working, all of us are coming at different levels, different angles. You need that supportive environment to learn. So that's been amazing. And then the last piece is we're just getting started on building our projects. And I was mind boggled just listening to people's ideas about what to build, things I'd never even thought about. So it's just broadening that perspective about the possibilities for me. And we haven't even started a project. So those are the three things that really stood out for me. And I hope you guys give this a chance because it's definitely been a positive experience for me.
Awesome. Thank you so much for sharing that. And yes, I'm so excited about the projects that are currently being built in our cohort. I think at some point we're going to do some sort of a demo day where the broader community can actually view some of these projects. I'm really blown away by a couple of them. Very, very interesting stuff. And the next cohort starts in about a month. So if you guys are interested, please sign up. There are a couple other people that are going to also share their experiences. Unfortunately, we have limited time, so we're going to have to hold off on that for next week. But thank you so much, Priyanka. This was an amazing session. I think everybody loved it. As you can tell, a lot of people wrote thank you notes, and I got a bunch of private messages as well. The video will be available also on LinkedIn and on YouTube, also soon on our website. So hope that we will have you around here again. And until next week, where we're going to go over the high levels of AI product management with Kai, one of the instructors at our AI product management cohort. And also any questions that people might have about the upcoming cohort, that would be great. And one thing that I will also announce to the existing cohort members and the alumni is all the new learning material that we're developing as the industry is evolving, it'll be available to you. So you'll have access to everything for 3 years. So anything new is going to be available. We're also doing a lot of new stuff around MLOps. It's becoming more and more important, and we want to stay ahead of it. So people that had the workshop on Tuesday, they loved it. We're going to do one right now in a few minutes. So thank you so much again, Priyanka, for coming in. We hope to have you again. And until next week, see you all. Bye.